Well, welcome everybody to our weekly class. I'm going to talk about some of the things I've been thinking about and writing about recently in this autobiography. And so I decided to start it not with the usual chronological order, but sort of a set of ideas that I'm going to refer to throughout. And the first one is first principles reasoning. And as Einstein said, everything's made as simple as possible, but not more so. So to explain what this is, I've got a few examples from classical mechanics. Newton's first law, I'm sure you're familiar with these. I say I'm sure, I don't know. It's inertia. An object will stay at rest or travel at a constant speed in a straight line unless acted on by an external force. And that's what it looks like as a formula. These are vectors and should have little arrows on top. I don't know how to do that. If anyone does, tell me, but I put the little underline on them to show their vectors, not scalar quantities. And I think if you think about this, it's, for me at least, it seems trivial at first. But reflect on it, it's not at all. It's philosophically a really important idea. So, and then the second law, F equals ma, is one of my very favorite equations. I love it because it's so simple. And for me, the way I think of this is it defines mass. It's not about force and acceleration. It defines mass. And mass is what it is because it does what it does. So that's kind of fun. Thoughts? Is this interesting, guys? Larissa?
Yeah, always
Nico?
to me, always to me.
Okay. The third law is
Yeah.
for every action, there's equal and opposite reaction. And more fundamentally, this is the conservation of momentum. So I'm fascinated that rockets can fly, and the reason is that you have this hot gas out the back of the rocket, and its MV has to exceed the inertia of the whole rocket on top of it. So the gas, since there's very little mass, the gas has to be really fast. And a rocket like the Space Shuttle main engine, the exhaust is 10,000 miles per hour, 15 times the speed of sound. So that's kind of interesting. In order to get a rocket to move, because you have very little mass, that's how fast the V's got to be. Make sense? So what is reality? I think what we're talking about is what most people would see as reality, these things, ordinary life. But as you likely know, when you look at the world that's different from ordinary life, things look very different indeed. In fact, they don't not only look different, they are different. And when you look at very fast, like approaching the speed of light, you get into what's called relativity. And very small, down to atomic scales, you're talking about quantum mechanics. The world works very differently in these realms. And then there's the world of the large, the universe. And this is the realm of astrophysics. And incredibly, I think we have a pretty good handle on quantum mechanics. It's the calculations are good to like 15 decimal places. A pretty good handle on relativity. By the way, the GPS won't work without relativistic corrections. But the universe, we don't know a damn thing about it, in the sense that not more than 95% of it is unknown to us. And so I put that's not a mistake. That's not a typographical error. I think you guys probably know this. 26% is what's called dark matter. All that is there's too much gravity. And 68% is dark energy, which is even more perplexing, verified by Hubble. And this is the idea that say if you take a ball and throw it in the air, it leaves your hand, it has a lot of kinetic energy. As it rises, that converts by the mass of the Earth into potential energy, then it falls back down. That's how we thought the universe worked, but more recently, this dark energy shows after, I think, 4 billion years, the universe is accelerating, and nobody knows what this is. It's like you throw a ball in the air, it looks like it's slowing, and then suddenly it takes off and heads out to infinity. So to physicists, this is fun. And Einstein said, two things are infinite, the universe and human stupidity. I'm not sure about the universe. I don't think we're stupid, just lazy when it comes to how we reason. So most people reason by analogy. And this is drawing conclusions from matters based on similarities that actually may not exist at all. So it also assumes the past is an accurate predictor of the future. And more specifically, tomorrow will be a mirror image of today. Now, why is this flawed way of thinking so common? First, it doesn't require much effort, and people are lazy. And second, it works well for short-term matters. In fact, I've read that until recently, maybe even now, weather forecasting, by assuming the weather's going to be the same tomorrow, is more accurate than the official forecast. So it kind of works. And if you think about humans, our genus has been on the planet 2 million years, genus Homo. We're tactically focused, and we're rewarded for being tactically focused. Survival was a short-term deal. I think primarily, where do we get our next meal? So if you listen to this, you'll find this line of reasoning everywhere. So Junko does this a lot. We're riding along, and she's very heavy into attribution of things. Traffic's heavy, she'll say it's Friday afternoon. And she's probably right. That's reasoning by analogy. Well, so what's the problem? Well, the problem is it ends the inquiry. Curiosity is dampened, perhaps eliminated. And it might not be that traffic's heavy because of Friday. It might be other reasons. It might be there's a traffic jam. It might be there's a special event, a Colorado football game or whatever. And this example doesn't matter much. It's not important. We know why the traffic is heavy on a certain day. But I just want to illustrate the limitations of this form of reasoning. It's not strategic. And I suggest that our main issues are all strategic. So economic growth, reasoning by analogy, people want economic growth. The governments worldwide advocate for it. They cheer it. People get worried about a recession. And so why is that? Well, growth increases employment and wealth. Stock market goes up and so forth. And we live in societies that are dominated by financial considerations. I'm really struck by the fact that I think the big banks control our politics more than elected people. It's about money. And also growth supports increased government spending. As the economy grows, governments can spend more. And mostly governments, and the jobs that politicians care about mostly are their own. And as the Bible says in 1 Timothy, the love of money is the root of all evil. That's often misquoted as money is the root of all evil. That's not what it says. The love of money is the root of all evil. So here's what's the problem. If you get out of that thinking by analogy and go to first principles, growth by any percent is exponential. And most people don't think much about this. You can use the rule of 72 to calculate the doubling time. If we assume, for example, 6% GDP growth, which is something I think most governments would love to have, the doubling time is 12 years. That's 72 divided by 6. So what does this mean? In 12 years, the economy has to be twice as large. In 24 years, 4 times as large. In 36 years, 8 times as large. 3% growth has exactly the same effect, just takes twice as long. In fact, 6% was the growth in 2021, and more like 3% over time. But here's the difficulty. Economic activity is literally proportional to energy consumption. And energy overwhelmingly, I think 98% is probably the accurate number, comes from non-replenishable fossil fuels. And here's what gets even crazier. Everybody wants to maintain the status quo. They want tomorrow to be like yesterday. So they think we can preserve this very fast resource depletion if we use more solar panels and windmills. This is nonsense. And energy costs money. There's no dispute about that. The oil primarily, or natural gas, need money to mine and extract. Where does the money come from to buy exponentially greater energy from? The answer is exponentially increasing debt. And given that the planet is finite and rapidly consuming everything, how is this resolved in terms of first principles thinking? It's not. I've seen estimates that say we need the resources of 3 Earths to support civilization as it currently exists, much less to grow. So comments or thoughts so far?
Mm,
No, this is really interesting. Thank you.
Okay.
No, coming
just
from,
one comment,
go
Yes.
ahead.
sure. Yeah, this whole idea of human beings being lazy to think, I always connect that with Edward de Bono. That draws me to his work like 30 years ago. And it is so true. And we stay in the same kind of thinking, repeating, you know, thoughts or ideas that's being from habits or tradition and not questioning it.
Yep.
So just the idea of realizing that we are usually too lazy to think, and then you start observing it.
Yeah, you see it everywhere once you start to name it. Larissa, thoughts?
Yes, coming from energy sector originally, it's not a surprise to me, and it's a separate sort of topic for a long discussion, how things are going in the energy sector. And but I'm an engineer, and may I say, sort of like good trained engineer. So it was an obvious thing for me since the beginning. Since
Yeah.
my first internship when I was like 17 years old, it was aha moment since then.
You see the insanity in the whole thing. Hmm?
I see it, and I see the whole picture. I don't know if you ever been in a, I don't know, oil and gas exploration field, and I don't know if you, I've been there since the first time when I dived into that sort of problems when I was 17. Yes. So, and there are no surprises. What you're talking about is just really painful thing, but it's obvious to me.
You're heading for it. So here's the summary. Things that can't go on forever won't.
Yeah.
Okay. So here's the bottom line. At the first principles level, I want you to think about this sentence. The natural earth is incompatible with industrial society. That's the basic problem. Jared Diamond, you may know him. His most famous book is called Guns, Germs, and Steel. One of the most interesting books I've ever read. He's an anthropologist, and he says widespread adoption by agriculture, which happened about 12,000 years ago, was the worst mistake in the history of the human race, a catastrophe from which we have never recovered. And what he's talking about is that we are dependent upon and integral with all the other ecosystems on this planet. And we've just left them all. And so, and you can see the data in everything. It's extinction of species, on and on and on. So, and I got this insight from a guy named Nate Higgins. Climate change is a waste disposal problem. It's not a problem of itself, it's a problem with growth. And so all this growth and all this increasing the economy simply creates more waste. It's that simple. And I call it a predicament, not the word problem, as problem implies a solution. There's no solution to this. Simply put, we have created far more waste product than the planet can process and continue to produce ever more. So people who think reason by analogy discount the increasingly extreme weather. I think you probably know there's a Category 5 hurricane heading for Florida right now. 180-mile-an-hour winds. And there's going to be more because hot water makes these. So people who reason by analogy, like the Republicans in Florida, discount the extreme weather as just that. People who choose to reason for first principles understand the following unfortunate realities. Humans are large vertebrate mammals, and we have a very low tolerance for heat. The brain and organ damage occur at wet bulb temperatures of 35 degrees centigrade or 95 degrees Fahrenheit. Wet bulb means 100% humidity. And of course, with lower humidity, the temperature goes up. And here's something else I think people don't think about. Earth was uninhabitable by humans until maybe 8 million years ago. And all of its 8 billion year period, large vertebrate mammals couldn't live on it. It's just simply too hot. And this current climate, the Holocene, which is when we switched to agriculture, is 12,800 years old, formed by a comet striking the frozen North America. So if we had chosen to continue to live in harmony with the other animals, we could go on for a very long time. But this choice to go with agriculture and all that entails, by the way, it's slavery, caste systems, cities, towns, wars, militaries, nuclear weapons, that all comes from this decision. So what's going on here with this? Well, the basic physics is that the visible light comes from, it's a black body temperature of 6,000 degrees Kelvin, comes from the sun, and it comes right through the Earth's atmosphere. You probably know all this, but I just like to go over it. And heats the surface. And the surface of the Earth has to get rid of that energy where it gets hotter and hotter and hotter. So it naturally radiates it. That's radiative equilibrium. And the surface temperature is about 293 degrees Kelvin. That's room temperature. And that emits in the infrared. So if you had infrared eyes, you'd look outside and everything's glowing. And it was discovered back, I think, 1820 by I think, Fourier, but certainly later by this Swedish science physicist in 1880, that there's absorption bands in water vapor and carbon dioxide for infrared radiation. So the problem is really simple. The radiation that the ground has to radiate, not to get hotter and hotter, is absorbed. It never leaves. So I think this is, here's the bottom line. We're going to go extinct and soon. There's no way around this that I can see. And the big question is when, and various people have predictions of this. I think that's a hard problem, too hard for me. I don't know when. I think it's within 10 or 20 years, but I'm not going to say that's a certainty. I think that I prefer to look at what I call a tell, what's going to indicate that the end is near, and that's Arctic going ice-free, and that might happen next year. And basically, the physics there is that during the summer, the Arctic gets enormous amounts of solar energy. In fact, the sun never sets; it's illuminated 24 hours a day. And the ice reflects 95% of the energy back. The minute that goes blue water, ice with a little bit of wind, and it's a windy place, absorbs that 95% of the energy. So I think you get like a factor of 2 increase immediately. And here's the other thing. People tend to think that zero emissions is a solution. This is a really important point. Eliminating emissions of greenhouse gases only changes the rate of increase of the heating, not the heating itself. I'm going to say that again. Introducing new greenhouse gases only changes the rate of increase of the heating, not the heating. The heating is going to get hotter and hotter and hotter as long as the blankets are in place. And the blankets are the CO2 that our waste product is put in the atmosphere. So there's no escape from this. It's going to get hotter and hotter and hotter, and all the other things that implies. Everybody clear on this? Okay, good. So show me the incentive and I'll show you the behavior. A famous quote from Charlie Munger, but I don't think original to him. I think it's clear that on the path we're on, the longer we continue, the sooner we're going to reach a catastrophic ending. There's been about, I don't know, some number 20 species of Homo. All the others are going extinct, and we're going to join them soon. Why don't we address this? Well, is anything that I told you here complicated? Is anything I told you hard to understand? No, it's just if you willing to think from first principles, this is quite easy. How about people who begin to talk about or think about this? The last person I know was Jimmy Carter. He was probably the last honest president, and he lost in a landslide. So I like this quote: "The hardest thing for a man to hear is that which he doesn't want to." So I hear this from friends of mine that are engineers like Larissa. Technology is going to save us. Well, I think Santa Claus is more likely. And when I ask people how this is going to happen, like my friend Jeff Bennett, who writes books about this, he says fusion energy is going to solve the problem. Well, the first issue is that there's not even a lab fusion experiment that makes more usable energy than it consumes, and people have been spending billions on this for 50 years. And even if you could, there's another calculation that's been published, several actually, that does basic thermodynamics. And if you were to add the energy that we need to have anything like the growth and civilization that we have, the Earth's going to overheat anyway. You've got another 30 years, but you cannot, the Earth is in homeostasis when most of it is grasses and trees and stuff. And then I hear that technology is going to make everything more efficient. This is a fact. Technology makes things more efficient. But in every instance of increased efficiency, and most notably air conditioning, the falling cost of use induces increases in demand such that the resource use is increased. There's even a name for this. It's called Jevons paradox. So I think actually technology is our trouble. And I'm going to explain this. It's deep in the hole we're in. Here's how. Well, we have this massive and temporary source of excess energy in fossil fuels. Does everybody understand this is temporary? This stuff took millions of years to form, and we're extracting it at a rate where it's going to be gone, I don't know, 10, 20 years, some very, very short time. We'd be in trouble already except for fracking. Fracking has given us some time. And of course, fracking is taking the oil out of the rocks. Once you've done that, I think you're done. And what's happened is with this big blast of very cheap energy, we've converted all our infrastructure for everything possible to use fossil fuel workers to replace human workers. I think the number today is there are 8 fossil fuel workers for every human worker. What that means is that fossil fuel is doing things that humans would be doing otherwise 8 times more. And just one of my favorite examples, it wasn't that long ago people milked cows by hand. I had a friend who worked on a dairy farm, and he could damn near crush my hands with his hands from milking cows. I don't think any cows in the developed world are milked by humans anymore. Got a missing word there. This one. So now machines milk cows. They go into a big thing, and I think today even the milking udders are attached automatically by the fossil workers. And giant machines. You take a look at American farms. These machines are so huge. Humans look small next to them. GPS controls them. And instead of fertilizing with manure, which is how things were done 100 years ago, now we use fertilizer from natural gas. Natural gas is cheap and abundant, it comes from fracking. And so we got this reprieve, but I think it's surely impossible to go back. So here's the problem: as things are temporarily okay, there's food in the grocery store today. Reasoning by analogy ignores the unfortunate reality of massive disruptions upon us on and soon. And is anyone talking about this? Is anybody preparing society for this? Nobody that I know. And here's the big thing, okay? The latest thing, AI, is making a new massive drain on energy. I just saw that Amazon has purchased the 3 Mile Island and is starting it back up to power AI computers. And I think the estimates are that AI is going to take like half our energy in some very short time, 5 years. do computations using supercomputers. So I say technology is not the savior, it's the problem. That's a controversial thing. Any comments or thoughts? Okay.
Well, Charlie,
Well, this is,
yeah, go ahead,
sorry,
Nico.
yeah, sorry,
Go ahead,
Larissa.
go ahead.
No, this is just reality. It's difficult. What do we do with this? I mean, if the four of us is like in control of the whole world, you know, what would we do? How do we change all of this? How do we stop it? I don't know.
Well,
It's not positive, but what do you do with reality?
I can tell you what I do. I maximize my comfort as this thing is upon us. That's my strategy. That's what everything here is about. Larissa, thoughts, comments?
No, my comments are along those lines, yes. So it's just something bigger than we could possibly. Yes, we can understand it. Yes, we can see the reason. Yes, we can see the scientific and technological and engineering background behind it. But the bottom line would still be the same. So, yes.
I like to think that somehow if enough of us become aware of this and maybe have two other friends understand it, at some point, the dialogue could come around to this. It's so simple. Have I told you anything hard to understand here?
No.
I mean, so, and what you would do with this is you would begin very simply to extend human life and comfort with things that you can do to give us more time. That's what you can do about this. You can't stop it, in my opinion, but you can delay it. And building solar panels and windmills does not delay it. It's the only thing that can delay it is acknowledging the growth has to be slowed or stopped. Economic growth. Who's going to stand up and get voted in for that? Anyway, I guess the fact that it's hopeless doesn't stop me from talking about it.
Well, that's good. That's good that you still have you still have, I don't know, energy and passion to really look into that issue, because to me it's just, I heard you first time, what is it, 12 years ago, or
Yeah.
what is it, 15 now years? So you answered all my questions, and it's obvious to me.
Yeah.
Yeah, I agree with you that general public will benefit from learning, just at least learning the truth. I guess that's all. But to me, it's a done deal. It's obvious for many years.
If you think about it, if you just think about it without, the whole point of this is that it's how you think about things. If you use first principles thinking, it's trivially obvious. If you use reasoning by analogy, you can't see it. That's
true.
And what I hope to do as I go through my autobiography is highlight places where I've had the good luck to use first principles thinking. That's what this is about. This is actually using examples to illustrate a thinking method.
Yeah, that's good. That's all good, Charlie. Thank you.
I don't know if you watch investment advice. I think you probably can't help it. It's in the news all the time. I watched a considerable amount of financial analysis. And the reason that I do is the world is financial, and financial analysis is kind of like a report on the world. And I think it's an interesting barometer about what's going on. But if you listen to what people say, it's 99% reasoning by analogy. It's so common, we have a term for it. It's called technical analysis. And,
Yeah.
okay. And I think I don't want to say think by analogy has no purpose. It's useful for traders. If you want to day trade, I think technical analysis and charting is extremely useful.
Yeah, absolutely.
But it doesn't do anything for the long term, just like the climate change example.
That's correct too.
You know, the first thing it does, it causes people to momentum invest. And what that means is that, and I've been guilty of this, you wait until something's really moving up nicely, then you buy it. And what that almost inevitably entails is suckering you into a bubble. I got suckered into a silver bubble some years ago. Again, first principles analysis. I've come to this because I can't replace these losses I've got like I did in the past. In the past, I had significant income and I could replace those funds. Now my income is extremely limited. So here's what's going on here. I think this is the first time in human history that all currencies are fiat. I don't know that that's absolutely true. There may have been some time, but if you go back to museums, things like shells were currencies. Some material thing was currency. You'll find the gold coins in Pharaoh's coffins. U.S. Constitution states flatly that nothing can settle debts except gold and silver. And so what happened is after World War II, everybody got together at Bretton Woods and decided on a new financial system, and the Keynesians won. And what they agreed was that all money in the world would be tied to dollars. And at that time, I believe the dollar was 40% gold, which, by the way, is the same thing the BRICS are doing this week, I think. So we were tied to gold. And the benefit of that is it limits government's ability to overspend. So along comes the Great Society and the Vietnam War and Nixon. And France is using this fact to take the physical gold out of New York and take it home. The US government doesn't like this. So Nixon has a press conference and he temporarily suspends the conversion of the dollar to gold. That temporary suspension happened in 1971. So now, with no brakes on anything, the central banks have lowered short-term interest rates to near zero for an extended period. And they're heading back there now. They're temporarily up right now. But the reason they're going back, just as an aside, is the US can't function with treasury bills costing 10%. Right now, the tax receipts, 70% of them go to the entitlements. And I've tried on a few people, why don't we make those means tested? I've gotten my head bit off, even by people who don't need the money. So what's happened so the near zero interest rates are there, keep interest rates down so the US government is solvent, for example. And when money's cheap, people borrow it. And and debt, this is kind of a new idea. Debt is energy brought forward. Money is energy. I mean, this is a big mindset shift that I made only in the past probably several months. Debt is energy, money is energy. So debt is energy brought forward. Where are you going to get the energy to repay this if you're running out of fossil fuels? I think the probability is epsilon. Familiar with mathematics, epsilon is a vanishingly small number. And so you're not going to repay it. What are you going to do? Well, first off, this default, I think that's very unlikely. The US government bond is kind of the gold standard for debt. If we ever defaulted on those, the world would go bankrupt into a depression in a hurry. The thing that's going to be done is the tried and true process of debasement. And we have a name for that. It's called inflation. And this report is a % increase. So it's another exponential function, just like I showed you before, a hockey stick. And just like climate change, people don't understand that if you got inflation back to zero, it doesn't solve the problem. The prices remain at the peak levels. So you have inflation at 10%, cost of everything goes up 10%. Hypothetically, if inflation goes to zero, they still stay up there at 10%. They don't go down. So the remedy that I prefer, as you all know, is physical gold. And there are lots of reasons for that, but fundamentally it's a store of value going back to the pharaohs. And I've had people argue with me, argue in a very constructive way. It has no inherent value. It's just metal. You can't drink it or eat it. Well, the counter argument, which I've found more recently that I find really interesting, think about this. If you were shipwrecked, for example, or in some way thrust into some part of the world with nothing but gold coins in your pocket, you'd be able to eat. Gold coins would buy you a meal, I think, any place in the world, Afghanistan or Russia. So So let me pause for a minute. Thoughts or comments? Is it making sense to you?
It does. I appreciate your financial advices and thoughts. It's just I have to confess that as much as I love following your logic, it doesn't unfortunately applies to my financial circumstances. So do I understand that we need to invest in gold? Yes, I do. Do I have money for it? No, I don't.
You can buy it in
So-
Costco, Larissa. You can buy it.
No, it's not about that. It's going to
Okay.
prolong, okay, for what for how much I can purchase, it's not going to make a difference. Yes, it will allow me to be alive and well for a couple more days if I would not compared to the circumstances if I would not buy it. But it's not going to make a principal difference. It's just for it's just I'm not in that top 2%, unfortunately. And
But
and
you know, my friend who's Turkish talks about the fact that in Turkey, every payday, every person that makes some money stops on the way home and buys a $1 silver or gold coin. It doesn't have to be a lot of money. So
yeah,
anyway,
that's a good advice. I might purchase some amount, but it's not going to make, yeah, it's going to really make a difference maybe here and there,
well,
but it's not going to change it in general.
what I'm really saying is that if you don't have any savings, I understand completely. But if you have savings in dollars, you're foolish to have them there. That's my real point.
Yeah, you may be right. Yeah.
So
Speaking of thinking of by analogy. Yeah, thank you, Charlie. I just want to say I appreciate that.
I will leave the conversation to the American friends I have.
so this is a new connection I made. Experiment, are they first principles? So this was something I thought of just last couple of weeks, mulling this over. So does this seem odd? So what is physics? Physics, this is my definition. Physics is a mathematical description of reality driven by experiments. Or there's a famous video clip of Richard Feynman teaching an undergraduate class that's actually kind of humorous. The students laugh about it. Is how do we do physics? Well, first you make a guess. That's what you call, the fancy word for that's a hypothesis. Then you compute the consequences. And if it disagrees with the experiment, it is wrong, period. It doesn't matter how elegant your math is, nothing else matters. So experimental data is kind of the ultimate real reality. And that's why in 4D, we measure our processes by measuring behavioral change, improvements. So I suggest good experimental data meets this test for first principles. These are direct from nature, virtues that cannot be further reduced. And I've been fascinated for a long time how very simple experiments have changed the course of physics in profound ways. So I'm going to write a little bit about this. This is a part of an autobiography about things that I find interesting. So what is the nature of matter? Well, people, so since forever, and I don't know how far back it goes, certainly since Newton, physicists thought that subatomic matter was smaller versions of ordinary stuff. And Ernst Rutherford, a very famous, I think it might be misspelled, I think it's R-U. Does anybody know? I think it's R-U, Rutherford. He is actually a physicist in New Zealand. He proposed a model in 1911 that remains popular with lay people to this day. I think that's what most people think about when they think about the nucleus. Atoms were analogous to the solar system. An atom is a small, dense, positively charged center called a nucleus, where most of the mass is, and negatively charged electrons around it as little objects. So is that how most of you think of subatomic physics, atomic physics? Is that model? I suspect so. So here's a really interesting experiment. It's called the two-slit experiment. And this was done many times. Most notably, a guy named Thomas Young did the experiment quite carefully, published the results. And what's interesting about this is you have a light source, a light bulb, if you will, a mask with two slits in it, and then you have a screen behind. The first thing you think you're going to see are two bright lines where the light comes through the two slits, right? That's the intuitive guess. But that's not what you see. You see the brightest area is right in the middle where it's totally dark. And this is explained by wave mechanics. I actually had a whole undergraduate semester in nothing but wave mechanics. And you can see the same thing if you go down to a beach and there's a jetty, the two openings at the shore of the ocean. When the waves come in, you'll see the interference pattern right there in front of you. And so this is a common thing. So far, so good, light's a wave and so forth. So how about quantum mechanics? Well, the first idea came from Einstein's paper, also written the same time as relativity, on the photoelectric effect, which got him a Nobel Prize. Most people think of Einstein as getting a Nobel Prize for relativity. That's not it, this photoelectric effect. And that didn't get much attention. But later, this two-slit experiment was done with electrons instead of light. And they used beams of electrons, and they got the same result. So they just said, okay, this is fine. I got it. Beams of electrons act like a beam of light. Then people did the experiment, carefully ensuring electrons only traveled one at a time. That is to say, there were never two electrons on the path at the same time. And you can easily see that with the screen in the back, you can see the individual quanta hitting. They had the same pattern as light. This became what's called wave particle duality. And the mathematical part that came from this is probability distribution functions, most notably the Schrodinger wave equation. And I hear people talk about quantum mechanics and trying to make it work in ordinary life. I don't know of any manifestations of ordinary life. It makes transistors work and things like this, but there's actually, I think Margaret Wheatley wrote a book called Quantum Mechanical Management, just nonsense to me. And Richard Feynman said, if you think you understand quantum mechanics, you don't understand quantum mechanics. So I think this is why physics is interesting to me. It is completely inconsistent with our intuition. What he's trying to say there is, if you want to understand this with analogies like Schrodinger's cat, it doesn't work. It's not an ordinary life thing. So Schrodinger's cat actually comes from something called the Copenhagen interpretation. And I don't care much about this. I think it's in the mathematics as the answer. So sunlight, comments or questions, thoughts, how are we doing? Okay, so
We're doing just fine. I just want to say I love Mr. Richard Feynman books, and especially the book with his humor, which is very famous in the the physics world.
Yeah.
So the one of the books that I really love is just "You Must Be Joking, Mr. Feynman." So, it's funny to those of us who have similar to Charlie's logic, and I am enjoying it very much. So thank you. It's a side note, but I just want to say it. Thank you, Charlie.
From my side, I'll just shut up and calculate.
Okay, good. So light, is it true we tend to take it for granted? Most people don't think much about the nature of light. The sun brings us plenty every morning, at least here in the Western US. It comes from the solar photosphere with a color temperature of 6,000 degrees Kelvin, visible light. What's interesting is the fact that it's a black body radiation makes it very concentrated, high temperature radiation with low entropy. What this means is that it's able to produce photosynthesis, which if the light were less ordered, wouldn't happen. So we're very lucky to have this kind of light radiation. So people pondered the speed of light, says Newton, and that they reasoned by analogy. It was like sound waves. You see, here's the problem, reasoning by analogy again. So what they believed was that they knew that sound needed air to move through space. Therefore, light also needed a medium, just like air, and they called it the ether. So the thought was that light is traveling on the ether, just like the sound waves are traveling on air. So given that everybody knows for many years the Earth's rotating and it's orbiting the sun, ether has to be moving through space. There's no way it can just be stationary. So they used interferometers. These are simply things that take light in two directions, two arms, and then beat the two against each other to see if there's a difference in the speed. And they got a null result. They saw no difference with light moving in two directions. But it was ignored because people didn't want to believe it. This is another human thing, confirmation bias. We tend to select the information from the data that supports our preconceived notions. This is another common human thing. So by 1887, two physicists who were very, very superb experimentalists did it so carefully that it could not be ignored. And they did this using an interferometer that was on a stone slab floating in an annular trough of mercury. So it was indisputable. And the error bars, what I mean indisputable is the error bars were so small and properly calculated. So there was a null result. The experiment, if it was intended to measure the speed of the ether, was a failed experiment. It's maybe the most important such result in physics. And the result is that the speed of light in vacuum, by the way, people get sloppy about this. Light slows down, for example, in water and glass, but the speed of light in a vacuum is a constant, a number. The ether does not exist. So immediately obvious consequence of this that people didn't think a lot about is that the speed of light, if something's moving towards you or away from you, is not additive. Again, common sense, if I'm driving down the road at 60 miles an hour and I throw a thing out the window straight ahead at 10 miles an hour, it's going 70 miles an hour. You add the speeds, that doesn't work. And Einstein thought about this and realized this was profound. And he was unable to get a job as a physicist. He's working in the patent office above the railway station. He did thought experiments. They're called Gedanken experiments in German. And what he wanted to do was he explored the meaning of simultaneity when trains were moving each other at very high speeds. He's over the train station, so he's thinking about trains. And he realizes you can't add the velocities, that is inconsistent with the speed of light being a constant. So I'm not going to derive it here, but the way you do this is the Lorentz transformation, which is gamma. It's 1 over the square root of the relative velocity of two objects divided by the speed of light. This is a profound violation of common sense. This is when physics became really interesting. And this is of course the field of special relativity, special meaning constant velocities. So I think it's obvious that reasoning by analogy would never have gotten us here. And Einstein wrote, if the Michelson-Morley experiment had not brought us into serious embarrassment, nobody would have regarded the relativity theory as a halfway redemption. So again, what I'm trying to show is how basic data from carefully done experiments is a first principle and gives you a whole new way of thinking about things. This is conceptually a very simple thing to do. You could build one in your house, and it wouldn't be precise enough to prove there's speed of light's a constant, but you could measure the speed of light in different directions in your kitchen table with this thing. So 10 years later, it took Einstein 10 more years. He worked through adding acceleration to it, and this is the field of general relativity. And what came out of this was a mechanism for gravity. So Newton's equations described motions of matter, but not what the mechanism was. So you think about F equals ma, it does nothing to tell you how it operates. So Einstein began thinking about this and positing with no evidence the equivalence principle. And what this means is that the acceleration of gravity and movement are physically equivalent. So let me be clear what we're talking about. I'm sitting in my chair right now and I'm feeling an acceleration pushing me downward from gravity, right? A force. If I were away from gravity and you accelerated this chair at g, one g, 32 feet per second squared, I would feel exactly the same force. That's the equivalence principle. I'm not sure how Einstein reasoned that, but I think he just thought they can't be different. By the way, this was validated in a rocket experiment by my friends at Stanford, maybe in the 80s, with a rocket experiment called Gravity Probe A. So here's where the thinking went. He imagined an elevator or a box that's constantly accelerating. Now, this is not real. You can't really do this because sooner or later, I mean, you can do it for a little while, you can't do it long. The elevator would approach the speed of light, but let's just ignore that. The elevator is accelerating, and he imagined a light source on one side of the elevator. And what he realized was that because the thing is accelerating, it's going to strike the other side at a lower location because the elevator moved during the time it took to transit the distance. The leap of logic was because the sources are equivalent, gravity could bend the light beam. This is really a big thing, this leap. I want you to make sure you get this. Gravity has zero rest mass. How can you bend something that has zero rest mass with gravity? The answer is this very simple experiment is the curvature of space-time is the mathematics. And Arthur Eddington, a British astronomer, confirmed this experimentally in the 1919 solar eclipse. So what he reasoned was that if you took really good telescopes and looked at stars behind the sun, which you can only do during an eclipse, that if Einstein's right, the gravity of the sun would bend the stars, and you see the stars moving into different positions as the sun went by. It's exactly what he saw. And of course, today, gravitational lensing is common. Hubble routinely sees it. So I just find this little story so interesting, how a Gedanken experiment about an accelerating elevator and the assumption that acceleration was the same as acceleration due to gravity led to this beautiful explanation of how gravity works. So I've got 4 minutes left. Should I continue? You guys want to talk?
Either way is fine. Yeah, to have some concluding thoughts might be great, but if you feel that you can squeeze in.
No, I think this. Well, let me stop here and just have an open floor because yeah, I can squeeze it in, but let's not do that. Let's comments or thoughts. So what I've been talking about is very fundamental matters. How we reason, primarily the difference between reasoning by analogy and reasoning from first principles. And this writing is all sort of new. I've never thought about this very much till I sat down and typed this out. Is this giving you guys some interesting insights into how you think?
Yes, for me it's very interesting. That's why I'm always here whenever I can make it. Anyone?
Yeah.
It is very new to me, so it will take me some time to process.
Yeah, it's a lot of information, isn't it?
It is simple concepts, but challenging to fully
Grasp.
understand and grasp. Yeah.
I find the story about the Gedanken experiment leading to the bending of light and therefore gravity bends light just absolutely fascinating. This is I came across this relatively recently, just poking around reading things. That when I was studying this material, I had no idea about this.
Interesting.
The leap of logic, and I don't know, I'm not clear, I've tried to look into this, how he included the accelerations due to gravity and movement were physically equivalent, the equivalence principle. I think in a way, it's intuitively obvious, how could there be two completely different mechanisms, but to put that into a near certainty for the purpose of this analysis is just, I mean, I think it shows the man's fantastic intuition and his ability to physically intuit things that turned out in 1980s to be actually fact.
Mhm.
Yes, Charlie, yes and yes. Yes on all the questions. I didn't know what else to say. I am enjoying every minute of it, and that's why I'm rushing every time. And I feel so bad if I'm not able to make it. So thank you for making the time for all of us to share your thoughts, and thank you for writing it. So hopefully I will do everything I could possibly do to help you publish it. And yeah, so the rest of the people who are not so privileged as we are would have a chance to really listen to your wisdom.
Thank you. Thank you for making the time for us, Charlie.
My pleasure.
Agreed.
I enjoy doing this. The fun thing for me, this is mostly new. This is mostly in the last just weeks, months, thinking about the idea of how we reason. So the idea that people are stupid is not the right way to think about this. I don't think Frank and I say that all the time. I think people don't stop and reason correctly. And I don't think it's hard, you know, maybe I should put this in here, that children do this. It's time to go to bed. Why?
Well,
Mhm.
there's a lot in here that makes one think, and what's going on through my mind, I've got to address politicians here in South Africa by the end of the month. And what's the message going to be to them in terms of the social entrepreneurship work I'm doing, but into the bigger picture, how communities and politicians obviously should change. But I mean, if you're sharing the reality that we dealt with during this hour, we all know what the reaction will be, just denial or
Yeah.
rationalized deviance. So, but yeah, we are privileged to be here to integrate, knowledge and realities.
Thank you all. See you next week. I'm planning to be here next week.
Excellent.
Yeah, great to see everybody. Thank you, Charlie. Thank you.
Thank you,
everyone.
Bye-bye.
Okay.
have a
Bye.
good week, folks.
Bye.
Thank
Great
you.
week. Okay.
Mull this over.
Will do.
Be well.